IM3.7.4, conditional probability and independent events.
Yay. Okay, so here for sample 1 we have a tree diagram of the number of students in the class, how many are male and how many are female, and how many are allergic and how many are not allergic. So let's say I wanted to figure out what's the probability of having a male student in the class that is allergic. The probability would be 12 out of 36 students. If I wanted to figure out what's the probability of having a female student that is not allergic, that probability would be 8 out of 36. Or we can come here and look at the table. It has the same information, it's just portrayed differently. Let's say I wanted to figure out how many male students were not allergic. I would come here to the male, not allergic, 7. The total number of students is 36, so 7 out of 36 students that are male have a probability, the probability of having a male allergic student in the class is 7 out of 36. And what I just explained is all conditional probability.
And then there's independent events, which means that the probability of A does not affect the probability of B. So, let's say that I have this box of shapes and I pull out a yellow square. If I take it out, that changes the entire probability of me picking out another yellow square. But if I put this yellow square back in, it doesn't change if I pick up another yellow square or a green square or a blue rectangle.
No, Kate.
That was so good, are you kidding me?
No, Kate. If you pick up a green square and then
We're going to have to redo this. Why are you doing this anyway?
Hold on. Kate, listen.
If you guys didn't act stupid and she just said, no, Kate, it would have been great because she would be like, proper thing.
Okay, no, Kate.
No, Kate.
If you pick out a green square and then put it back in, that's an independent event because it's not going to affect the next shape that I pull out. But let's say if I take this green square out, it is going to affect because now I have one less green square in the whole box.
Okay, let's start over now. And then there are the independent events. This means that the probability of A will not affect the probability of B. So let's say I have a bag full of green and yellow squares. If I pull out a yellow square and put it back in, this does not affect the probability of me picking out another different shape.
Okay, so we have an example of dependent events, and dependent events are just the probability that A is true given that B is true. So here we have an example. You can either have a tree diagram for it or like a chart like we showed before. And for an example, what's the probability that a person that likes the film is a female? We can go right here and look under the people that like it, and female, it's 42, so it would be, it's like in the same order as it's stated right here, so female is 42 over 66. And then there's another example, what's the probability of it being a female? There's a total of 60 female out of 100, so it's 60 out of 100. And thirdly, what's the probability that a male is someone who likes the film? So we go to the male, and it's a total of 40%, and the ones that like it is 24%, so it's 24% over 40%. Okay, we're back again because Mr. Olson asked for us to explain that this is not a fraction. This means that if a person likes the film, what's the probability that it's a female? Right, Mr. Olson?
Right.
It's not a fraction, guys.